All right, guys. So for today, we're going to be talking about trigonometric functions or of any angle. So up to this point, we have only been working with common angles. Right? So we've been working like 30, 45, 60, 90, so on and so forth. But we're going to be looking at how we can evaluate trig functions of any angle. And so first off, what we have here is theta is an angle in standard position with xy being a point on the terminal side. Right. So here, if I find a point right here, we'll call this xy, such that when I drop down an altitude, okay, it creates the horizontal distance, which is our x. It creates the vertical distance, which is our y. And we're going to call the length of this terminal side, we're going to call that r. Okay, now you can see here that we create a right triangle. And so in essence, okay, r is hypotenuse. All right, and so this is just a version of the Pythagorean theorem, the x squared plus y squared. We're going to go ahead and take the square root of it. Okay, and so with that, we can evaluate our six trig functions. So if we say sine of theta, right? Now remember, this is theta. This is our triangle. Okay, and so this is the reference angle. But we know that sine of theta is equal to sine of the reference angle, okay, pending the quadrant that it's in. All right. So for instance, if it's in quadrant 1, they're all positive. If it's in quadrant 2, sine is positive, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. Right. So pending that. So we can say that this and these two are going to give us equivalent values. So when I evaluate sine of theta, we can use this reference angle right here. All right. So either way, we know that theta is opposite over hypotenuse. Right, which is y over r. Up to this point, we've been able to say that the sine value is just the y, right, but that's because we've been referencing the unit circle where the radius is just 1. So if the radius was 1, y divided by 1 would just be y. Right? But now, because we're looking at a radius of something other than 1, all right, we're not necessarily in the unit circle, we have to actually divide it by r. Okay. Same thing with cosine. All right, cosine of theta is the adjacent over hypotenuse, which normally it's x, but now we're not just dividing by 1, so it's going to be x over r. And tangent is opposite over hypotenuse, which is y over x. Okay. If we know these, then we can also find their inverse functions. The secant of theta is 1 over the sine, which equals r over y. Cosecant of theta is 1 over the cosine, which when we simplify that, it's r over x. And cotangent is the inverse of tangent, which is 1 over y over x, which simplifies to x over y. Right? So we can evaluate our six trig functions using these, right, pending this information. So taking a look at the first example here. Example 1 says that we're going to use a point on the terminal side to evaluate the trig functions. So example 1 says, let negative 3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So I'm going to go ahead and draw out this diagram. All right. I'm going to identify the point negative 3, 4. Draw my line from the origin. Okay, and represent the angle. All right, so this is theta right here. Okay. Now, whenever I do this to kind of get a visual, at least in these first couple, I'm going to go ahead and drop the altitude. All right. Get a perpendicular line. So, and label it negative 3, 4. Now, obviously, in distances, when we talk about distance, we can't have a negative or a positive, but we're going to go ahead and use those negatives and positives because we are talking about points in a coordinate plane. All right, and so we want to find r first. So r is going to equal to the square root of x squared plus y squared. So that's 9 plus 16, which is the square root of 25, which is 5. All right, so my radius is 5. All right, so now it wants us to find sine of theta, okay, which sine we know is opposite over hypotenuse, or the y over the r. Cosine of theta, all right, up above we said was x over r, so x is a negative 3 over 5. And tangent of theta is opposite over hypotenuse, or the x over the y, it's 4 over 3. All right, now let's check, let's verify. All right, so see if I made a mistake. So we know in quadrant 1, all of them are positive. Quadrant 2, sine is positive. All students take calculus. All students take calculus. So we're in quadrant 2, so sine should be the only positive. Cosine's -3/5, tangent, and that's where I did it. I forgot to put the negative with the 3. Okay? And so those are those 3 trig ratios. And then we can also identify cosecant, secant, and cotangent by taking the reciprocal of those. Right? The only time we have to you can take the reciprocal. The only time you just want to be careful in terms of just taking the reciprocal is if you have 0 involved. Because if you end up with 0 in the denominator, for instance, if you get tangent of theta is equal to 0, the reciprocal is going to be undefined, right? Because you can't have 0 in the denominator. All right. So the next one, all right? So this one says, given that tangent of theta is -5/4, and cosine of theta is greater than 0, right? So this just means that it's positive. All right, and we want to find sine of theta and secant of theta, all right? So first off, let's think about this, okay? So we think all students take calculus. Sine of theta is -5/4. All right. We know that tangent of theta is the y divided by the x, right? Okay. Well, there are 2 quadrants where tangent could potentially be negative, right? It could be negative here, and it could be negative here. It's not going to be in quadrant 1 or 3 because those have to be positive. All right, so we have to take into consideration. It could be here, it could be here. And that's why this information right here is necessary. All right, because it says that theta also, or cosine of theta is greater than 0, meaning it has to be positive. All right, well, in quadrant 2, it can't be positive. So we know our terminal side is going to be in quadrant 4. All right, so tangent of theta is a -5/4. It's going to rotate around. Right, and we're going to say this is the y, the top is the y, so we're going to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. All right, so I'm going to go ahead and drop my altitude just to get a better visual. My y is a -5, my x is 4, and now we need to find the r. Okay, so I'm going to go ahead and just find it down here. R is the square root of 4 squared plus -5 squared. 16 plus 25, which is the square root of 41. All right, and that does not simplify. All right, so now we have all the information that we need. So if I want to find sine of theta, okay, so remember, this is theta. This is big angle right here is theta. But the reference angle is the equivalent. Okay, so we can still use this angle within that triangle to identify those, just as long as we make sure we pay attention to the signs. All right, so sine of theta is opposite over our hypotenuse. So it's -5 over the square root of 41. We can never have a radical in the denominator, so I'm going to rationalize. That's -5 square root of 41 over 41. All right, and so this is sine of theta. And secant of theta is equal to 1 over cosine of theta. And cosine of theta, right? So we don't necessarily have to know that. So if you can remember from the original that secant of theta is r over y, then you can just say it's r over y, square root of 41 over -5. But if you can't remember that specifically and you want to find the cosine, remember cosine is, sorry, I lied on these notes. You need to go back up through here. Secant is not the inverse of sine. This is cosecant. Cosecant is not the inverse of cosine. This is sine. Or this is secant. All right? Sorry, I lied on that. So go back through and make that adjustment there. All right. So secant of theta is 1 over cosine. And cosine, all right, so secant should be r over x. Okay, because cosine is 4 over the square root of 41. We multiply by the reciprocal, and I get square root of 41 over 4. All right, so that's how we can use a given point, right, in order to evaluate the other trig functions. So let's go down to example number 2. This says to find 2 solutions for theta in both radians and degrees. So basically what we're doing here is we have cosine of theta is equal to square root of 2 over 2. We are trying to find a value for theta to make this true. And so one thing we want to recognize is that this is one of our common points on a circle, right? And we recognize this as a multiple of our 45 degrees or our pi's over 4. Okay, so this is where it's super helpful to know the unit circle front and back, right? Because cosine of theta gives us a positive value, right? So it can't be here, can't be here. So because this is a multiple of 45 degrees, I'm going to identify my reference angles inside inside of this. Hold on, guys, just 1 second. All right, guys, so if we recognize that this is a multiple of 45 degrees, we know quadrant 1, we have 45 degrees or pi over 4. And this gives us coordinates of square root of 2 over 2, square root of 2 over 2. And in quadrant 4, we have angle measurements of 315 or 7 pi over 4. Okay, and this gives us coordinates of square root of 2 over 2, negative square root of 2 over 2. But the only ones that we really care about are the x values. Okay, and so because cosine of theta is square root of 2 over 2 and square root of 2 over here, my answers for theta in degrees, we can say 45 degrees or 315 degrees. Okay, or we can say pi over 4 or 7 pi over 4. Okay, all right. So let's take a look at one more here. Okay, and then we'll be done. All right, so this one we have cosecant of theta is equal to negative square root of 3 over 3. So one thing we want to think about, all right, this right here we don't immediately recognize. But we do know that cosecant of theta, 1 over sine of theta, right? So sine, that's where we get our best values. So if I go ahead and take 1 over this and simplify, this is going to give us what sine of theta is equal to, right? So I'm going to multiply by the reciprocal. So I get 3 over negative 2 square root of 3. I'm going to rationalize. So I get 3 square root of 3 over negative 2 times 3. Right? So here those 3's are going to simplify, and so we get square root of 3 over negative 2. Okay. All right. So the sine value should be a negative square root of 3 over 2. So if we think about our unit circle, sine is negative in quadrants 3 and 4. Right? And so those are going to have, these come from our multiples or our reference angle of 60 degrees or pi over 3. Okay, so in quadrant 3, this is going to give us 240 degrees or 4 pi over 3. And in quadrant 4, this is going to give us 300 degrees or 5 pi over 3. Okay, so it gives us those two specific values right there. So those, and so at this, remember our coordinates are negative 1/2, negative square root of 3 over 2. And here our coordinates are positive 1/2, negative square root of 3 over 2. Once again, all we really care about are the y values, right? Because we know the y values are associated with sine. And so our solutions in degrees are going to be 240 and 300. And in radians, it's going to be 4 pi over 3 and 5 pi over 3. Okay. All right, guys, that's it for today.